Hello, so in this video we're going to talk about how to write Pythonic setters and getters, or how to actually write the real setters and getter in Python. Okay, so just a review, what are getters and setters? Well, we use getters when we want to read some instance attributes, and we want to use setters when we either want to change or set um, instance attributes, right? That's what getters and setters for. Now, this has been the way that we've been writing getters and setters. Get make, set make, and use those in wherever we need them. So, what's wrong with the way that we've been doing, or we've been writing setters and getters? Well, for one thing, in the initializer, for example, if the value for make is invalid, we did not inform the caller that instantiate an instance of car. Instead, we silently set the make instance attribute to some default value. Okay, so and that's not good, because one of the sense of Python is actually error should never pass silently, right? So just as an example, here I instantiate a car with a blank make. Now, does the definition does the definition of the car class, does it tell me? No, it does not. However, when I print out the instance of the car I just created, I see that the make is some unknown value. It's not what I told it to, even though it didn't inform me that it didn't like it. Okay, so that's one of the problems, right? And then another problem is, for those of you who've done Java or C++, this is really kind of the way that Java writes getters and setters. But we are writing Python code, right? We're not writing Java code. And then finally, writing setters this way, the client code can still access the attributes directly, the make attribute directly, without using the setters and getters, right? And by doing that, it can set it to some bad value, right? So it can set it to some bad make, and when we print the make out, we see that, yeah, now make has some bad values. So none of these are good. Let me set it back to valid values, so to kind of set up for the later demonstration. Anyway, so along the same line of thought, what if, on the other hand, that we actually do have a lot of code that access these attributes directly already, like what we just did. Now, most of these code are probably doing the right thing, right? However, maybe some of them is setting it to the wrong value and we don't even know it. So it would be actually very nice if we can force all these code to go through the setters and getters, but particularly setters, for validation, so that we can actually catch the errors. But we don't want to change all the existing code because, like I said, there might be a lot of them already. It might not be feasible to change all of the existing code to use the setter syntax here. So the fact is, actually, it's such a common thing to do. It's such a nice thing to do. Python actually has a way to allow us to seemingly access the attributes directly. However, it would go through a setters and getters that we defined. Okay, so I'm going to show you how to do that. So the first thing when we want to kind of convert these Java-ish setters or getters into Pythonic getters and setters, well, we'll start with getters. Okay, so the first thing is, like we learned earlier in a separate video, that we can kind of make these attributes private, right, by prefixing it with an underscore. So we'll do that first. And so let's do it for make. So in the setter for make, I'm going to make an underscore, and getter for make, I'm going to put an underscore in front of it, and obviously in the initializer here, I'm going to put an underscore in front of it. So now I only changed the internal representation, so nothing should broken here hopefully. So I'll run it. Oh boy. Okay. Right. Right. Because now I'm well. That's because I access the attributes directly, so that's not good. I didn't go through the setters and getters before, but like I said, we would like the client code to be able to do this. So that's okay. Now we changed the internal representation. The next step is, okay, let's write a Pythonic getter. And in order to do that, I will actually make the getter into what's called a Python property. And I'll make a property by using the property, the magical property decorator. Okay, so I declare a property, and the name of the property should be make. Okay, so I get rid of the word get in front of the name of the property, so it's just make. Now, this is kind of a, looks like kind of a magical syntax. What this is still a method. However, to call this method, we don't have to do like kind of the normal call method, because the fact that it's declared with a add property decorator, I can actually access it as if it's an instance attribute. Okay, so let me get rid of all of these first. So here it looks like the syntax here, it looks like I'm accessing an attribute. Even though when I call this, and because the fact that we are just reading the attribute, right? We're not setting the attribute here. This is a right-hand side RHS access. We're reading it. So it would actually just call this method, and this method will return the attribute underscore make. So now when we run it, voila, it actually accesses the make attribute. Okay, so that is kind of the first step into writing a Pythonic getter. This is actually a Pythonic getter, or the better name is it's now a Python property. Okay. Now another interesting observation is if I actually try to set this property, quote unquote, okay, and when I run it, it says hey, you cannot set this attribute, and the reason is that we only define kind of a getter here. We don't have a setter, right? Because the setter is called setMake. So it just complains. You can't do this anymore, which is kind of nice if all you want is a read-only attribute, and there are uses for read-only attributes. So this is good enough if that's what you want. All right, so moving on, we do want to allow the client code to be able to change it. So how do we then change the previous setter to a real Pythonic setter? All right, so the way to do it is we come back to the setter. We have a setter here. So now that we have a property called make, we want to build a setter for the property make. So we start with the magical decorator again. The first thing is the decorator is the name of the property, which is called make. And then I do a dot and setter. Now it's not happy with that because at this point it doesn't know what make is. So I have to put the property in front of the setter. Okay? Now the setter, we shouldn't call it just setMake. We can just call it the same name as the property. All right. So yeah, the syntax looks slightly interesting, or and the fact that we actually have two make methods now, but one, this property, this is a getter. This second one is a setter for make. Okay, let me see. I think this doesn't work just yet because I'm still in the initializer. I'm calling the setter. I'm calling the old setter, so it doesn't work anymore. And to use the new setter, we basically just do as if we put the property on the left-hand side of an assignment operator, as if it's just a normal attribute. But here, this syntax, because the fact that this property now is on the left-hand side of an assignment operator, it knows to call the method for this property. And what is the value of new make? Well, it's whatever value we are assigning to this property. Okay, so let's see if this should work. I am hoping it will. So let me run it. There. So we started with Honda, and let me actually try to print this out. Yeah, this print should also work. Okay, so the original car, the make is Honda, so it is here Honda, and we actually set it to Tesla, and when we print it out, it prints out as Tesla. So again, car2.make, just the fact that it's on the left-hand side of the assignment operator, it will call a setter. Okay, and car2.make, given that it's in this line of code, it is a reaccess, it will call the getter. Okay, so far so good, I think. Yes. So the next interesting thing is, what about the return false here? Right? Because in the previous setter, if we do some validations, and if the new value is invalid, we want to return false to tell the caller that something is invalid. But if you look at the syntax for setting the value now, what does even return false mean in this case? Like, this thing will return false, and then who's going to be able to check the false value or the true value? Well, you cannot not this way. So we need a different way of reporting error for this case. And what is the different way of reporting error that we actually did learn? Well, it's raising exceptions, right? So in this case, we should, if the new make is invalid, if it's neither Honda or Tesla, we'll raise. I guess in this case it should be a value error, right? The new value for make it's wrong. So we'll just say, let's say invalid make. I'll just print it out, perhaps. Format new make. All right. So here, this is the way to report an error, and if it's not an error, then we don't need to return anything. We just set it. So nothing to do here. All right. So this should nothing change here. Everything should still work. Now here's the magic, or well, not so really magic, but here's how it's gonna look like when I set something to like a bad make here. Okay, so when I run it, and there, the setter is called, and then the new make, because the new make is bad make, is neither Honda nor Tesla, so a value error is raised. A value error is raised with the message invalid make, bad make. Okay, so that's good. So we prevent a bad value from being assigned to make. Now, the even more interesting thing here is, okay, what about in the initializer? I actually set it to another bad value for make. Let's say a blank. When we run it, we actually are informed now that because the blank is a bad value at the time of initialization. So that would be this line, right? At this line 70, at this line, we are informed there is something wrong with the make. So the invalid value and error is no longer passed, silently passed, right? We now have to deal with the invalid value because our program crashed otherwise. Okay. Yes. So this is basically what the slide is going to say. And also, and then the additional advantage is that if you look at here, we will no longer need to have a default make because if the new value for the make is bad, the user knows, so we don't have to silently kind of change whatever the invalid value that the caller tells us to set to to some default good value. So we don't even need that anymore. All right. So that's really that, and this is a summary of what we just did. You can kind of go through it yourself. And now let's look back at there was a number of reasons that we kind of set out to do the getters and the setters the right way, and have we achieved all of those goals? Well, so let's look at this. When we are the setter, so the setter validation, we said before that in the old setter, even though we return true or false, the caller is not obligated to check them, right? However, now, because an exception is raised, the caller has to deal with the fact that if something goes wrong, then it has to take the appropriate action. So the setter validation can no longer be ignored. So that's good. The second goal, the initializer, if it gets bad initial values, it also raises exceptions. So any error there, again, can not be ignored either. So that's good. Okay, and then the third thing is now the client code actually looks simple, right? This is how you set something. It's almost like setting a variable directly. And then this is like reading a variable or reading an attribute directly. So the syntax is actually simple in terms of the client code. Now, I know the definition of the setter and the getter now has these decorators, and they look a little, they look different, I guess. But after you do it a few times, they are not that bad. And then finally, if there was code that previously that actually accessed the attributes directly, now they no longer do that. They'll go through the setters and getters, but they don't need to be changed, right? So this is all of the good things about the Pythonic getters and the setters. Alright, so after you sing this, you should really try to practice a little bit on your own. So there are a few other attributes, in this piece of the car code, the car definition, there's the model year and there's also the price. So I suggest that you actually write some client test code to either read or write these attributes directly. And when you do the setter, maybe sometimes you want to set it to an invalid value. And then also you should create some instances, and some of the initial values should probably be invalid. Now you should convert these attributes into the properties and define the Python getters and setters for them. And so when you do that, after you do that, your existing client code should continue to work, except those that are setting invalid values, because they will cause exception to be raised. And then you can either try to handle it or print out an error message and things like that. So please go ahead and give the Pythonic getters and setter a try.